Good evening, everyone. Welcome back to the shop for part 3 of our series on making steel out of iron. This is where we left off last week. And tonight we're going to weld a knife out of the steel that we had created, out of the little billets. First, we're going to break apart the fold that we had made last week. If we had proceeded straight on to welding up the billets from the bars that we made last week, that fold would have been perfect, but as it is, it's had a week to sit and oxidize, and we're going to have to improve the surface, and that's what we're going to start doing right now. Now, there's a couple of times where I'm going to hold the bars to the camera and show you the surface finish, and what I'm trying to do is show the visible layering to the camera, but I'm afraid that wasn't picked up very well by the camera. But the layers in the steel are very visible to the naked eye. Every imperfection that you can see there is a barrier to a successful weld. So we have to get that all off. We have to make our potential weld surfaces as clean and as friendly to a diffusion weld as we possibly can. Otherwise, there's just going to be a lot of failures, a lot of inclusions, a lot of striations, which is very common in artifacts from the medieval period, but that's not what we're going for. Now we have our bars fitted tightly together. It's time to trim them up. You'll notice each one is a different length, and that's purely by accident. It's absolutely possible to work with different length stock and weld up a successful blade, but not to get the blade that we're looking for. We're going for a Norse seax, specifically a Norwegian seax this time. And in order to get the herringbone pattern down the spine of the blade, we have to have our bars nearly the same length. There's actually a little bit we can do to work with different lengths because of the way the blade will be bent to shape, but you'll see that a little bit later. Now I'm welding up the stack. I'm only doing in tacking. Again, I'm not doing anything fancy like a zero atmosphere weld. Although that would probably make the weld more successful, it does make the process less illustrative for historically minded smiths. So what we're going to be working with is the situation that historic smiths were working with, where every weld seam had to be carefully monitored, and that'll be important later on. The forge I work with is a Chile forge. I'm very happy with it. There are a number of YouTube blacksmiths who are working with Chile forges, and I think their burners are just the best in the business. For Venturi burners, forced air burners are a different animal, and of course, those are much more powerful. But for the Venturi process, especially for a beginner to intermediate smith, I can't recommend Chile forge enough. I'm using light hammer blows to weld up the stack, and as I've said before, every weld step should be performed 3 times. First to tack, then to set, and then to blend. We're setting the welds. And the reason for that is because of the mechanics of diffusion welding. All fire welding, all forge welding is a species of diffusion weld. And diffusion welds happen when the atomic surface, or the atoms of the different surfaces, diffuse and mingle together to such an extent that there's no longer any difference between the two surfaces. And that's really a function of heat and pressure and time. Now we're over at the hydraulic press, and for tonight's project I'm only going to use the press for drawing out Where a historic smith would have had the assistance of a striker, I'm going to use the press, but for everything else, I'll be working on the anvil, and you'll see that. I'm using a very gentle fullering die here, and I'm doing that for a couple of reasons. A fullering die is exactly what you need to draw out your piece, draw the length out of your piece, but the fullering die you may have seen in previous videos is much more aggressive, and right now we're working perpendicular to the plane of the weld. As I've mentioned in previous videos, that's the most stressful thing that you can do on your welds. So you want to make sure that your process is gentle, and you want to make sure that you go back to the anvil and reset those welds, because again, diffusion welds is a function of pressure, heat, and time to allow those surfaces to intermingle. And if you have pressure in the opposite direction, away from the plane of the weld, you can pop those diffusion welds apart. And that happens very easily in smithing, especially with fairly primitive steels. And historic construction techniques. Modern knife smithing techniques have completely eliminated a lot of these stresses from the process, but that's not the objective. You can't get historic results without at least a few historic techniques. So we're going to be drawing out gently with a gently curved die. You might say, well, why not just use two flat dies? And that is more gentle on the welds, but actually the sharp faces of my flat dies will cause bumps and ridges inside or on the face of my surface, and can cause cold shots. That's really just a function of how those dies were made. But they're very good dies. Now we are back to the flat dies, and we're drawing out in the opposite direction. We're drawing out with the planes of the welds, and we're going to make sure that our billet is nice and flat and straight, so that our pattern is nice and flat and straight. And you'll see me reflux many times throughout this project, because, well, maintaining those weld seams is very important. And you'll see why later on. Now, we're just about to start tapering the primary bevel of the blade. And we'll be working on this for quite a while, because we're doing it all by hand, with this bar construction. Tapering the knife by hand is absolutely the safest way to go. I would not want a chance doing this with mechanical assistance. It's just way too likely that those welds will pop apart. Something that you can do with hand hammering is drive. You're not hammering straight down. You're hammering the work back into itself. So there's much less stress against those diffusion welds. You're much less likely to pop them apart. And ultimately, I will. I will pop the edge of one of these welds apart, and you'll see that here in a minute. But if you work trying to get additional width out of your billet at this stage, because this is the wrong stage to get additional width out of the billet. You will, because you're reducing its cross section. But if you try and draw it out, like with a fuller, going the opposite direction, or with a cross peen, you'll pop those welds apart very quickly, and it'll be ugly, and then you'll have a heck of a time trying to drive it back together. So almost every other step, I'm working to reset and reseat those welds, and then flipping over to work on that bevel. And it's a process. You can only have admiration for historic smiths and how carefully they had to husband their work, and how callous they might have to be to sacrifice it when it had gone wrong. Now here in the beveling process, I'm hitting a lot harder than you've probably seen me working before. You want a lot of energy put into this. You want to strike from the shoulder. You don't want to strike from the wrist or from the elbow. Your arms will thank you later. Trust me on that. But also, the more energy that you deliver, not straight down, we're actually going a little bit sideways. We're driving the material back into itself, and that's going to put a lot less stress on those diffusion welds. It's a little bit later, the piece is cooler. I'm really happy with how that first beveling has come out. And now it's time to take off the front little bit of the weld. The edges, the ends of welds are never very good material, so you want to get rid of them. We're going to mark that out and take it over to the grinder. Of course, you can do that hot. You can use a hot cut, and that was done in period. However, you get, depending on how you build the shape of your hot cut, you can wind up with a lot of pattern distortion. It can be actually very ugly on the end of your knife. The way to prevent that is to have a hot cut that is only beveled on one side, and I've actually worked with building one of those, but it's not done yet, so I'm not going to do that process hot. But you can. Here we're rolling over the end of the knife and turning the bottom of the knife into the center of the knife. And that way the pattern on the blade will flow much more fluidly. We do see that in Norse construction, seaxes, in drop point knives, drop point and clip point seaxes. We see that. Not so much on Anglo-Saxon blades, although there was much variety in Anglo-Saxon blades, but the broken back seax, you typically see the blade, the bit of the blade, only running along the bottom, and the pattern truncated with the clip on the top. Now here I'm back to beveling the blade, and I have a hardy tool that I'm setting the back of the blade against to aid in making sure that there's less stress on those welds, but something has gone wrong, and we have a delamination developing. So you flux it up, you see if you can set it back together. It'll work for a little while, but the same stresses that pulled it apart are going to keep pulling it apart because I'm not doing anything different. Ultimately, if you have a seam that fails, the best thing to do is to cut it off and work with a smaller billet. And that's exactly what I wind up doing. I think I do that off screen, but I'll be chasing this seam around for a little while. I think here I've just cut it off. And it behaves nicely for the rest of the build process. I lost about a half an inch. But that's okay. We have plenty of metal to deal with. We'll have a very nice, healthy sized blade. But it's only illustrative. If I, in a modern shop, am dealing with this, our predecessors, how much more did they have to chase the same problems? And how much more worthy were their results? It's really impressive when you think about it. Here, I think I'm paranoid of having another seam open on me, so I'm doing as much work on the bottom of the blade as I am on the side of the blade. But it worked out well. I didn't get any more seams opening up. I'm getting to be really happy with the shape of that blade. I'd like it to be a little bit more drop pointed, but this is perfectly within historical parameters. Now I think I'm paranoid of opening up seams inside the blade billet. That ultimately didn't happen, but who knows? An ounce of prevention is better than a pound of cure. Now, since I'm happy with the shape of the blade, it's time to start working on the tang. And that bar I've been holding with breaks off very easily, and we'll move over to tongs. And the first thing we have to do is portion off a section of the material to become the tang. And I'm doing that with the hydraulic press. I'm using the two flattening dies to act as a hot set. The way that you would do that operation in historic times is with an assistant. The smith would hold a hot set, which looks like a hammer that has very sharp edges, and the edge of the anvil, and the assistant would strike, and you'd portion off that material. And then, of course, the rest of it can be worked by hand with a hammer, which is exactly what I'm doing. There are tools called guillotine tools that will allow a smith working alone to isolate material the same way. But guillotine tools were invented in the United States. They're really not historic, although they are hand tools. The tangs of seaxes, not uniquely, but certainly unusually to modernize, are only partial tangs. They will only go a portion of the way through the handle. But you need to make sure that any partial tang you do will at least sit under the middle of the hand. If the tang doesn't sit at least in the middle of the hand in use, and it's a cutting knife, a stabbing blade is a little bit different, but a cutting blade that doesn't sit under at least the ring finger is going to break out of the handle in use. So you need to make sure that your tang is at least long enough to do that. And this one is. We've got 5 inches of material there. It'll be just fine. But it's something to keep in mind when working with historic blade types. And I think this particular blade just turned out beautifully. I'm very happy with it. Thank you so much, all. See you in the next video.
Thank you for checking out my YouTube channel. If you enjoyed this video and would like to watch more of my videos, please follow the links on the left-hand side. Remember to select thumbs up that you like the video. It helps with the algorithm. If you have any questions or comments, please post them below. And please click subscribe and ring that bell to be updated when new videos come out.